Of all the moons in the solar system, one has always stood out for its eerie, almost artificial appearance. Mimas, a small icy satellite of Saturn, is instantly recognizable because of its colossal impact crater, a feature so dominant that it makes the moon look like the Death Star from Star Wars. For decades, scientists viewed Mimas as a geologically dead world, a frozen, battered relic, a relic of the violent early solar system. But in 2024, new analysis revealed something astonishing. Hidden beneath its ancient cratered shell, Mimas is not dead. It has a vast global subsurface ocean. This discovery has completely upended our understanding and raised profound questions about habitability. Mimas is tiny, only about 400 kilometers across, yet it is one of the most recognizable objects in the Saturn system. The giant Herschel Crater, named after the moon's discoverer William Herschel, spans nearly 130 kilometers, almost one-third of the moon's diameter. If a crater of similar relative size existed on Earth, it would be larger than Australia. The impact that created Herschel was cataclysmic. Simulations suggest it came dangerously close to shattering Mimas completely. Shockwaves from the collision focused on the opposite side of the moon, ripping apart the crust and creating a complex network of fractures. For decades, the heavily cratered, rigid surface led scientists to conclude that Mimas was a cold, solid, geologically inactive world. It was the textbook example of a dead moon. But as we'll see, the surface was only telling half the story. The first clue that something was wrong came from NASA's Cassini spacecraft. In 2010, Cassini mapped Mimas's surface temperature using its infrared spectrometer. Scientists expected a smooth gradient, warmer at the equator, colder at the poles. Instead, they found something bizarre. They found a sharp V-shaped Pac-Man thermal boundary on the leading hemisphere. Inside the mouth, temperatures dropped dramatically, while surrounding regions were warmer. This thermal anomaly had no visible counterpart in regular light images. It was as if something invisible was affecting the moon's heat distribution. The mystery was just beginning. This invisible influence was the first hint of the massive secret Mimas was keeping. The Pac-Man feature was initially attributed to how Mimas interacts with Saturn's radiation belts. High-energy particles bombard the leading face, compacting the surface ice and changing its thermal properties. But as more data came in, scientists realized this explanation was incomplete. Something deeper was going on beneath the surface. Something that would eventually lead to one of the most surprising discoveries. A discovery that would change everything we thought we knew about this small, dead moon. For years, Mimas was dismissed as a boring frozen fossil. But the new analysis of Cassini data has completely rewritten its story. Beneath its battered, cratered exterior lies a vast global ocean of liquid water, a hidden sea that changes everything we thought we knew about this small moon. The mystery of the Pac-Man thermal anomaly finally has an answer, and it's more extraordinary than we ever imagined. The first major clue that Mimas was hiding something extraordinary came from NASA's Cassini spacecraft in 2010. While mapping the moon's surface temperature, scientists discovered something bizarre. Instead of a smooth gradient, they discovered a sharp, V-shaped cold region on the leading hemisphere that looked exactly like the mouth of the Pac-Man character. Inside this mouth, temperatures dropped dramatically, while the surrounding regions were warmer. This thermal anomaly had no obvious counterpart in visible light images. It was as if something invisible was influencing the moon's heat distribution from below. The mystery was deepening, and the invisible influence suggested a secret far more significant than anyone had initially imagined. In 2024, after years of careful reanalysis, a team of researchers published a groundbreaking study. They concluded that Mimas harbors a vast global subsurface ocean of liquid water beneath its icy crust. The ocean is estimated to be 20-30 kilometers deep and lies roughly 30 kilometers beneath the surface. This hidden sea is kept liquid by tidal heating from Saturn's gravitational pull. As Mimas orbits in its slightly eccentric path, this tidal energy generates enough heat to maintain the liquid layer despite the extreme cold of deep space. The discovery was met with both excitement and disbelief. Mimas is the smallest known body in the solar system with a confirmed global subsurface ocean, smaller even than Enceladus. It challenges everything we thought we knew about how moons maintain heat. rewriting the rules for habitability in our solar system. The revelation immediately invited comparisons with Enceladus, Saturn's more famous ocean moon. While Enceladus actively vents water into space through its south polar geysers, Mimas keeps its ocean completely hidden beneath a thick, rigid ice shell. This difference makes Mimas potentially even more interesting for astrobiology. A hidden ocean might offer more stable conditions for the development of life. We got Mimas so wrong for decades because its surface told a story of geological death, while its interior was hiding one of the most exciting possibilities in the solar system. The tiny moon that looked like the Death Star from the outside has revealed itself to be one of the most intriguing ocean worlds in our solar system. To understand how we got Mimas so wrong, we need to go back to the beginning. When Voyager 2 flew past Saturn in 1980, it captured the first close-up images of Mimas. The moon's most striking feature was immediately obvious: the enormous Herschel Crater. Scientists concluded that Mimas was a cold, solid, geologically dead world. This interpretation dominated planetary science for decades. Mimas was often used as the textbook example of a dead, small, icy body. Even after Cassini arrived in the Saturn system in 2004 and began its long mission, Mimas was not considered a high-priority target. The data seemed to confirm the old view. Its surface showed no obvious signs of activity: no cryovolcanoes, no fresh fractures, no geysers. Mimas was filed away as boring. The conventional wisdom became, Enceladus is alive, Mimas is dead. Then, years later, analysis of the libration, the moon's slight wobble, revealed something shocking. The only way to explain the observations is a global subsurface ocean. The moon you thought was dead has been hiding a vast liquid water sea all along. The revelation of Mimas's global ocean is a powerful lesson in humility for planetary science. Even with multiple spacecraft visits, we can still fundamentally misunderstand a world based on its surface. Mimas teaches us that what we see on the outside often tells only part of the story, especially for small icy bodies with hidden subsurface oceans. The confirmation of a global subsurface ocean on Mimas is one of the most surprising discoveries. Its ocean lies roughly 20 to 30 kilometers beneath the surface and is estimated to be 32 to 40 kilometers deep. This makes it a thinner ocean shell than Enceladus, but still a vast body of liquid water on a world only 396 kilometers across. It's a miracle of planetary physics. The ocean is kept liquid through tidal heating, the gravitational squeezing and stretching from Saturn. This energy maintains the liquid layer despite the extreme cold of deep space. The discovery immediately raised the question of habitability. A global ocean of liquid water is one of the key ingredients for life as we know it. Combined with possible hydrothermal activity at the ocean floor, Mimas could potentially have the chemical energy sources needed for microbial life. The ocean is completely isolated beneath a thick ice shell, which could provide protection from radiation and micrometeorites, creating a stable environment for life. While we have no direct evidence of life, the conditions are intriguing enough that astrobiologists are now seriously considering Mimas as a target for future exploration. Mimas has gone from a boring dead world to one of the most exciting places in the solar system to search for life beyond Earth. Mimas has undergone one of the most dramatic reinterpretations in modern planetary science. For decades, it was dismissed as a cold, dead, heavily cratered relic, the boring moon of Saturn. The new analysis of Cassini data, combined with sophisticated modeling, has completely rewritten its story. Beneath its ancient surface lies a global subsurface ocean of liquid water, making Mimas the smallest known ocean world in the solar system. This discovery is a powerful reminder of how much we can still get wrong, even about objects we have observed multiple times. The implications extend far beyond Mimas itself. It shows that small icy moons can maintain global oceans for billions of years if tidal heating is sufficient. It expands our inventory of potentially habitable environments and demonstrates that surface appearance can be highly misleading. What looks dead may be very much alive. Let us end with a thought experiment. Imagine the year 2045. A dedicated Mimas mission arrives in the Saturn system. An orbiter maps the ice shell thickness and libration in exquisite detail. A lander touches down near the equator and deploys a cryobot that slowly melts its way through kilometers of ice to reach the hidden ocean below. For the first time, we sample the waters of Mimas directly. What would we find? Simple microbial life? Complex chemistry? Or a sterile ocean that nevertheless tells us valuable lessons about the conditions necessary for life to emerge? Whatever the result, the mission would represent one of the most profound explorations in human history. Reaching into the hidden interior of a world we once thought was dead, it's a vision of a future where we finally uncover the secrets of the solar system's smallest ocean world. Mimas teaches us a profound lesson in humility and wonder. We can observe a world multiple times with spacecraft, study its surface in detail, and still fundamentally misunderstand what lies beneath. The tiny moon that looked like the Death Star from the outside has revealed itself to be one of the most intriguing and potentially habitable worlds in our solar system. It reminds us that the solar system is full of surprises, even in places we thought we knew, and it gives us hope that life, or at least the conditions for life, may be more common in the outer solar system than we previously dared to imagine. In the end, Mimas shows us that the most incredible secrets can be hidden right in plain sight. Thank you for joining me on this long, detailed journey into the surprising story of Mimas. How did we get this small moon so wrong for so long? What do you think about the possibility of a hidden ocean world right here in our solar system? Drop your thoughts in the comments. I read every single one. If you love these extended, deeply researched explorations into the mysteries of our solar system and galactic origins, please hit like, subscribe to Galactic Origins, and turn on notifications so you never miss an episode. This is Galactic Origins, uncovering the hidden wonders and surprises of our cosmic neighborhood. Until next time, keep looking up with curiosity and an open mind.